Hello students, as per your demand, let's learn today your BPT theorem of class X. Okay. So you can read the theorem, what it means. So in a theorem, generally there are 4 steps to be followed. First, data given, then to prove. First of all, data given, then proof, then construction needed, and finally the proof. Okay. So, what is data given? What is the question? You know, you can read, open your page of BPT theorem and learn. Just read it over 2 times. It means if a line parallel to one side of a triangle, suppose ABC triangle, if a line parallel to one side of a triangle intersect the other 2 sides at 2 different points, then this parallel line intersect these 2 sides in the same ratio. This is the Thales theorem or BPT theorem. Okay? It means that a parallel line cuts 2 sides of a triangle proportionally. A parallel line cuts 2 sides of a triangle, these 2 sides of a triangle, in the same ratio or proportionally. It means that AX by BX will be equal to AY by CY. So, first, what we need, we have to draw the diagram as per instruction from the theorem itself. Okay, let's ABC a triangle. So, data given. What is ABC? Is a triangle and a line XY, okay, intersect XY, okay, let's parallel XY parallel to BC, okay, suppose XY is parallel to BC. BC at 2 different points. Okay. This is XY and parallel line T. Let parallel line T parallel to BC intersect on the 2 sides means AB and AC. AB and AC at X and Y. Okay. It means it is given T parallel BC. Okay. So we have to prove. What is to prove? What is to prove? AX by BX proportional. These 2 sides of triangle proportional. AX by BX equal to AY by CY. Okay, we have to prove this one. This is the BPT theorem. Okay, so what needed? Construction. If extra, not in all theorem construction is needed, but in certain theorem there is some construction that to be followed extra in the figure. So what will be the construction? Always remember the construction part, what extra needed to prove a theorem. And that is join CX and BY. Okay. So extra construction are made in this way by dotted line. Okay. So join by and cx. by and cx. Okay. Now three steps are there. Now proof. The final steps is proof. Now we will go towards proof. Okay. You know that the area of a triangle is half base into height. Okay. So look at the figure. Look at the triangle A, Y and B. ABY triangle. Okay. It has a common what? Common Y point. Okay. See this one in this figure. Suppose A, B, C and another D. Okay. So what if this is the right angle at X? So area of ABD and area of ACD. You have to calculate area of AXY and area of BXY. So just learn from this with this figure. Area of ABX, area of ABD will be how much? Half base into height. Half base is BD into height AX. If it is perpendicular, half base into height. Similarly, area of ACD will be how much? Half base CD into height, the same AX. Okay. So area of ACD divided by area of ACD will be how, what? If we will divide this one, then this will be divided by this also. Half AX cancel because the height is same here. So BD by CD. It means BD by CD means base by base. The base of triangle ABD to triangle ACD. Okay. Now compare here. In the same case is here, but the triangles are, you have to see from this way. Triangle YAB. The height is same. Height will be same because they are on a same line but different base. So what will be the height? Perpendicular height will be there like this. So don't take this. If you understand this one, you can write directly. Okay. So I am writing here. See, if you understood this part, then you can understand here. So in triangle YAB, see YAB triangle, area of triangle what? AXY to the area of triangle BXY will be how much? See, having same base, having same height, it will be the ratio of their corresponding base. So base of AXY is AX and base of AXY is AX and base of BXY is BX. AX by BX. Could you follow up to this? Okay, let's proceed. Now see from this side the triangle AXC. Okay, here we have seen ABY. Now we'll see ACX. Okay, ACX, because in ACX In ACX, AY and CY both are present. That's why I am choosing ACX. In triangle ACX, ACX. Okay. See, if this is the common X point, this will be the perpendicular. So leave it. It will be same for both triangle. So area of what? AXY divided by area of CXY. Area of CXY. Okay. From this side. This one. AXY to CXY. Okay. Both are on the same line and height is same. That's why the ratio will be the ratio of their area will be the ratio of its base. So base of AXY is AY and base of CXY is CY. Okay. Now let's proceed. This is half part completed of this theorem. Now see how this will be equal to this. We have to make this and this equal in what way? See the triangles BXY and CXY from this side. So make yourself sitting here and see carefully from this side BYX and CXY having the same base XY and they both are present between the perpendicular line T and BC. If two triangles are present in between two perpendicular lines having same base will be same. Then see triangle, if this is also a triangle and this is also a triangle having same base and between same perpendicular line like this. So the area of these two triangles will be same or not? The area of ABC will be how much? Half into BC into this and this. These two are same because they are parallel line. The distance between two parallel lines is always same. So if this is AX and this dy, half BC into AX and this is half BC into dy and BC cancel, half cancel and AX is dy because the distance between two parallel lines is always same. So AX is the distance between two parallel lines and dy also the distance between two parallel lines. So this is also same. So they are same. So now this will be applied here. See, the same case is present here. These two BXY and CXY are present having same base XY and they are between two parallel lines T and BC. It means area of BXY is equal to area of BXY and CXY. BXY and CXY. Okay. So area of BXY and area of CXY are same. Okay. So I can write here. Suppose this is equation 1. This is equation 2. In place of BXY, I can write CXY. You have to write both are present in same within the same parallel line T and BC and having same base xy. Okay, you have to write this one because I cannot write just equal the area of two parallel lines, area of two triangles. Okay, so I can write now, see, area of AXY by area of, see here, instead of BXY I can write CXY because same, I am writing CXY. Okay, what will be there? AXY, AY by CY, AXY by CXY. I am writing this instead of BXY, I am writing CXY, AY by CY. Okay. Now compare these two. This is third one. Now compare one and third. AXY by CXY, AY by CY, AXY by BXY, AY by CY, AX by BX. Now I can write also the here BXY, AXY by BXY. The same. If this one is same, then I can write this one and equal to this one. Now I can finalize. Hence, from equation 1 and 3, I can write AX by BX equal to AY by CY. Proved. Now you can write proved. Okay. In what point you are facing difficulty? Tell me. After making the area of this one is equal to area of CXY, having this part explained, you can write, instead of BXY, I can write CXY. Okay, AXY by CXY. Okay, if this part is same, okay, then area of AXY also same. So if this part is same and the numerator is already same and the denominator is same now by proof. So this part, this ratio having the same value, the value will be same to this one. Okay. So if this LHS part is same, we can write RHS part same. Because AX by BX has value, certain value, which is same to the AY by CY. So I can write AX by BX equal to AY by CY. Okay. So watch the video carefully, step by step, will be perfect to do the theorem.